One of the most common calculations that we do with any lab or any measurement that we might make is a percent error calculation, and it's a way to determine just how accurate we have been either with our measurement or with a calculated value such as density. The equation that we use, we're going to compare what we got, the experimental value, to what is an accepted value or a reference value, and we can obtain that from a textbook or a reference book, sometimes online sources if they're credible sources we can use for those reference values. But to calculate percent error, you first take the difference between what you got, the experimental error, and the reference value, which is the accepted value. And notice that you've got those absolute value symbols. All right. Basically what that means is that positive or negative, whatever that difference comes out to be, you're going to end up with a positive number. You drop the negative sign. Then you're going to take that difference and divide it by the reference value. And then once you divide that, then you're going to multiply by 100. This is one of the few times that you're going to hear me tell you that it's okay to just round off to the nearest whole number, that you don't have to worry about significant digits with your rounding. So if we take a look at some examples here, we've got three different sets of values here. And in the first one, we've got an experimental value of 265 centimeters. Our reference value in this particular example is 270 centimeters. And so what we're going to do is we're going to subtract 265 minus 270 centimeters. And that difference is a -5, but don't forget about the absolute value. So we'll take the absolute value of that, which would be 5 centimeters, divide it by the reference value, 270 centimeters. And when we divide that out and multiply by 100, remember it's okay to round off your percent error to the nearest whole percentage, because again it's a way for us to gauge how close were we to the value that we should have gotten. The smaller the value is, the better. The larger it is, the more we might want to take a look at our work, what we actually did. If you get a number that's less than 1%, that's great, but we don't want to report it as 0 because there might still be a little bit of error there. So if it's less than 1, round it off to the nearest 1/10%. So you should get 2% for that first example. All right. Now we got two more here. So rather than me go through it, why don't you take a moment here and go ahead and pause the video. All right. Work these last couple out, and while you're doing that, my coffee's empty, so I'm going to go get a cup of coffee. Be back in a minute. All right, let's get back to it. So for our second example there, we've got an experimental value 52.5 milliliters, all right, and our reference value 55.0 milliliters. So when we plug those numbers in, all right, you should come up with the final value of 5%, rounded off to the nearest whole percent. For the next example, all right, 2.50 kilograms and 2.15 kilograms, you can see that you should have come out with a percentage of 16%.